Okay, we'll discuss today the questions of this assignment, which is based on the second topic and the third topic. Okay, second law of motion and third law of motion. So everyone can derive the law of conservation of momentum. Razi, can you derive the law of conservation of momentum? The expression for the law of conservation of momentum.
Yes, no, I think so.
You can derive it.
No, ma'am, I can't.
What about you, Advika? Advika, are you there? She just has joined and where is she? And Shazan has also not joined yet.
Ma'am, 1 second, I'll just rejoin.
Okay. Hello? Razi, can you switch on your camera? And
Ma'am, I'm joined with my smartphone. Uncle, my sister is working on my laptop.
okay. Please once derive the formula that law of conservation of momentum. Derive once by yourself and just send it to me in the group.
Okay, ma'am.
Yeah.
Okay, ma'am.
Yes, Arham.
Yes, ma'am.
Yeah, I just asked to derive once the formula of this that I derived on.
Ma'am, I don't remember.
Remember that. So easy to say, Aram. So easy to say that you don't have to remember this thing. You don't have to remember that thing.
Good evening, ma'am.
Good evening. Shazan, have you remembered that formula I derived? The law of conservation of momentum.
Yes, ma'am.
Can you derive it by yourself?
Sure.
Okay, so just derive it once, and then we'll be doing some of the questions on the third law.
And we need to write that before collision, after collision, these all. We need to make diagrams.
Yeah, diagram.
Okay, ma'am. Yes, I'll send it to you.
Yes, then send it to me so that I can see that where the people are making mistake in there. It's very important for me. Advika, are you there or not? Still not?
Ma'am, I'm there. I was in the washroom.
Can you derive the formula?
Ma'am, the one we did in last class?
Yes.
Ma'am, I can try to.
Yes, yes. Just try.
Yes.
Try to go through the PDF that I shared.
Ma'am, handout?
Yes.
Ma'am, the handout or the one you shared in the group?
I know. Yeah, handed also, but also the PDF that I share after the class. Share after the class. That the taught one. Okay. That how I have derived it. What I have taught. What we have
Ma'am,
discussed.
you can't derive the formula of momentum. Ma'am, you know the formula of momentum last class.
Momentum. This formula. Law of conservation of momentum. This one. Okay. So you have to derive this. This.
Oh, okay, yes, ma'am. Ma'am, 1 second. I'll just. Ma'am, can I like drive in my notebook and then tell you? Ma'am, I got it. Ma'am, is it the ma'am, is it the M1U1, that one, right?
Yes. Yes.
Yes, ma'am. So should I tell you? Ma'am, can I tell you how I derived it?
No. I'm asking you to derive it right now.
Ma'am, should I do it in my notebook and then send it in the group? Hello?
Yes.
Ma'am, should I do it in my notebook, derive it right now and send it in the group?
Yes. Do it in your notebook and send it in the group. Yes. This is what I'm saying.
Oh, okay, yes, 1 second.
And you can mute, Advika, you can mute. There's some noise are coming from the background.
Ma'am, I'm done.
Have you done? Just send it to me in the group.
Ma'am, did you get it? Absent. Ma'am, did you get it?
Yes. Yes, I got it. Let me copy it and paste it. So you have taken A and B.
Yes, ma'am.
Okay. MAMB, UIUB after collision. MAMB, UIUB. Yes. PT. PT means?
Ma'am, prove that.
Okay. What's that? I thought you should have written two proof. Okay. UIUB, UIUB, FB, they go to MA. Okay. Yeah, correct. Razi, after where you have reached?
Ma'am, I sent.
You've sent. Okay. And what about you, Advika?
Hello?
Yes, have you sent it, Advika?
Ma'am, I sent it, yes. Yes, ma'am. Ma'am, I sent it like 5 minutes ago.
You have sent it. You have sent, yes, you have already sent it. If there will be one page now, that would be more easy to. Isn't it very small, Advika? Where is the diagram? Okay, Aram, you too have sent it.
Ma'am, I tried.
Razi, it will be in like this.
1 second, I'll send it after, ma'am.
MB, like this, okay?
Okay, ma'am.
Not like this. Not like this. It will be in the suffix. They're like MB. Okay.
Okay, ma'am.
I sent again.
Okay. How you have written and this change in momentum. You haven't drawn the diagram, Razi.
I have drawn the. Oh, you're telling Rosie.
Razi, you haven't drawn the diagram. I have drawn the
Ma'am,
diagram.
I have just written written there, ma'am. Below before, ma'am, M1 moving with U1, and then they collide, and then after that.
And there is no any kind of like F1, yeah, there is a diagram using after collision. So it will be like FAB is equal to minus FBA. You must have mentioned this because using second law of motion, using third law of motion, it will be, you have to mention it now that we are using third law of motion in order to derive the law of conservation of momentum. Okay?
Ma'am, second law of motion or third
Third,
law of motion?
third law of motion.
Okay, ma'am.
Third law of motion. Okay? Okay, you have to mention this.
Okay, ma'am. Ma'am, I've done the diagram on the other page. I sent it.
And yours also, it's very short and it's not completed. It's not completed, Advika.
Ma'am, it's on the next page, ma'am. Ma'am, like, no, can you type, ma'am, the second page? Should I send it?
Hmm.
In the
Okay.
same time.
Arham,
It's fine.
with the yellow one, have you written this? I don't think that you have written this.
No, I have written this.
Oh,
Ma'am, can you see me?
it's not your handwriting.
Yes, I've written it.
Is it your handwriting?
Yeah, it is. But here's the yellow pen.
Okay. And these two pages are why?
No, the first one I sent like, and then I edited a little bit, and then I sent again.
Okay. Okay. This one is not. No? Okay, fine. Okay, means everyone is knowing how has remembered. Everyone have remembered key how to derive the formula, right? And
Yes,
everyone has understood. Okay, so let us do some of the question. I think first one you can do. So let's not waste our time in doing the first question. Let's just discuss it. That how let me know that how you are going to do. A box of mass 50 kg is pulled by a force of 80 Newton. So we are given mass and we are given force. Okay. Find the acceleration. What is that? What is acceleration? You all are knowing F is equal to ma. So A will be what? F by m. Right?
Left by
yes, ma'am.
F by m. If the mass of the box is doubled, so it has doubled in the question, the mass of the box has been doubled. Okay. It means it has gone doubled means it has become 100 kg. Okay. And same force pull it. So force will be the same. So whatever force means 80 Newton, it will be the same, right? What is the new acceleration? So new acceleration will be what? Again, it will be A is equal to F by M. So whatever we will get the value of A after dividing F by M. Fine?
Yes, ma'am.
Okay, this will be the value of A, our new acceleration. Okay. A constant force acts on an object of mass 2 kg for 10 seconds and increases its velocity from I think I should. No, wait. Okay, now the second question. Second question. Okay. A constant force acts on an object of mass 2 kg for 10 seconds and increases its velocity from this to this. Okay. It means we are given what which quantities we are given? We are given mass, okay, is equal to 2 kg. We are given time is equal to 10 seconds. We are given increases its velocity from 5 meter per second to 10 meter per second. It means we are given u as 5 meter per second and v as 10 meter per second. Find the magnitude of applied force. So everyone can find it. Yes, or no?
Yes,
Yes,
ma'am.
ma'am.
Obviously, because F is equal to ma means A is equal to V minus U by T, and all quantities we are knowing. Okay, so we can find easily the value for F. Now, what now the in this question, the second part is asking if the force was applied for a duration of 15 seconds. It means we have to do what? We have to change the value of second as changed value of second as t is equal to what? 15 seconds. Okay, what would be the velocity of the object? So what will be the if the force means force will be the same. Okay, whatever force we'll get here, whatever Newton, something Newton like F Newton. Okay, F is some value. Okay, so suppose F Newton we are getting any value. F means any value, constant value. Okay, so F value we are force now we have F is equal to F Newton. Okay, fine. Now what it's asking the velocity of the object. So what would be the velocity of the object? Means in the starting u was 5 meter per second. So when u was 5 meter per second, now this time, the time has got changed from 10 second to 15 second. Only we have to change the time. Now we have to find v. Okay, v we are not knowing because it's asking the time has got changed. So it's not given like what velocity it has attained, right? It has it's only saying the force is applied. Force is applied. The same force. The same force is applied. Force is not getting changed. Okay, force is not getting changed, but the time duration, because time duration has got changed, so velocity will also get changed. Okay, so we have to find v. Mass will be equal to 2 kg. Same. Okay, so we have to find here again the formula will be the same, m v minus u by t. So we have to find here v. We have to find here v, right? So we'll apply this. We'll just rearrange the equation. So t will go to the f. Okay, t will go to the left hand side, and m will also come to the left hand side in the denominator because earlier it is in the numerator and it is in multiplication form. And here v minus u. Now u will also go to this side in what? So this, by calculating this, we'll get the value for v. We'll get the value for v. Okay, this will be our the equation of solving the for solving the value of v. Got it? Anyone? If anyone has not got it,
Got it, ma'am.
Got it, ma'am.
got it? Advika, you got it?
Ma'am, this formula I have derived before.
Yes, yes.
Ma'am, I have derived this formula.
I didn't get you.
Ma'am, I have derived this formula.
Mom, I've done a question like this.
Yes,
Which
ma'am.
which formula?
Ma'am,
This?
t by m plus u equal to v. Yes, ma'am.
This is just a rearrangement of the formula, right? This is just the
Yes.
yeah. This means even it's not necessary to rearrange it. You can directly put the value here in this equation and then find the value for v, right? You can directly put the values in this equation, or you can rearrange in this form also. Okay, because I'm not putting the values now right now because you people have to put the values. I'm just giving you the glimpse of the solution. Okay, you yourself can put the values now. If you will be having any problem, then just interrupt me. That please put the values so that we can do the question. Okay. Third question, what it's saying, the boy of mass 60 kg running at 3 meter per second square jumps on a trolley. Okay, now this we have to do. This question I will do because this is based on Newton's third law of motion. So this question I will do. A boy of mass 60 kg running at 3 meter per second. Okay, so let the mass of boy be mb. Okay, 60 kg. And running at 3 meter per second, it means it's no, let it be m1. It will be more easy. So u1 is what? Running at 3 meter per second. 3 meter per second. So the speed of boy is 3 meter per second. Jumps on a trolley of mass 140 kg, moving with a velocity of 1.5 meter per second in the same direction. Means trolley is also moving in the same direction. Okay. Trolley is having the mass 140 kg, and it's also because it's the initial velocity, so u2 will take u, and since it is the second mass, means we are talking about m2, so we'll take u2. So it will be 1.5 meter per second. Okay, in the same direction, so the direction will be the same. What is the common velocity? What is the common velocity? See here, the boy is there, right? It's running. Okay, it's running. He is running. Sorry, he is running. Trolley is there. Okay, trolley is there, like cart or something. Okay, cart is he is having mass. He is having mass 60 kg. Okay, and the cart is having mass, or you say trolley is having mass 140 kg. Okay, and then u1 means the velocity of the boy. Okay, he is running with the velocity of 3 meter per second, means this u1, and the trolley is also moving with the velocity of initial velocity of 1.5 meter per second. Okay, when this boy will come over this cart, means this boy by after running will come over this cart. Okay, this boy has come over this cart. Okay, and so what will be the velocity of this combined? What will be the combined velocity? Means now this m1 is over the m2, right? This boy is over this 60 kg is over this 140 kg. So we'll just consider this as m1 plus m2. Means this will become what? One mass, right? m1 plus m2. So whatever be the velocity of this cart will be the velocity of this boy. Are you getting this point?
Yes, ma'am.
Are you getting this point? Whatever be the velocity After that, it has come over this trolley. Okay, the boy has come over this trolley. So whatever be the velocity, whatever be the velocity of trolley will be the velocity of the boy also. It means if we are going to write in the formula like using the law of conservation momentum. Okay, what is the law of conservation? M1 U1 plus M2 U2. The writing the formula is must. M1 V1 plus M2 V2. Okay. Now we are knowing about we are knowing these values. Okay, M1 U1 and M2 U2. Right? We are knowing these values. What we are not knowing is V1 and V2. And now here you see, when this boy has come over this cart, over this trolley, then the velocity will become the same of both of them. Means V1 will be equal to V2, which will be which we can write as V. Can we take as V common velocity of both of them? Advika and Razik, Shazam, Aram, everyone getting not this point. When you are in a bus, okay, and you are sitting in a bus, whatever be the velocity of bus will be considered as the same velocity as yours, right? If you are not traveling inside the bus, if you are not moving inside the bus, with what velocity let us suppose that bus is moving with 80 kilometer per hour. Okay, bus is moving with traveling with 80 kilometer per hour, and you are sitting on the bus. You will be reaching at some point with the same velocity, right? Or your velocity will be different. Means the bus will reach at some point at 7 p.m. and you will reach there at 8 p.m. Will it be so?
No, ma'am.
You will reach at the same time, right? Because you will also use the same velocity as that of the bus, right? Or not?
Yes, ma'am.
It means you can
Yes,
consider
ma'am.
V1 and V2 as V because both will having the same velocity, right? It means we can write it like M1 U1 plus M2 U2 is equal to M1 plus M2 into V. Can we write it in this way? Can we write it in this way?
Yes, ma'am.
Shazan, you are not getting?
No, ma'am.
Ma'am, because
I'm not
M1 and
getting.
V1 are equal, then we will take it as common.
What? Where you are getting problem, Shazan?
In the part which you explained right now.
What I explained just now. I
And
just
that
explained here
bus
when the boy was out of the trolley, he was having some other velocity, and the trolley was having another velocity, right?
Yes,
And
ma'am.
when the boy has come over this trolley, okay, has come over this trolley means has stand up on the trolley, stood up in the trolley, and trolley will be having some velocity. Trolley will change its velocity.
Yes, ma'am.
Yes or no? Trolley will change its velocity because some force has got into this. So some force has got exerted into this because this boy has came with some momentum. Is it so?
Yes, ma'am.
Shazan is not getting.
ma'am, I understand.
Razi, you have got it. You got this point now. Now both will be having same velocity because
Yes, ma'am. Same velocity.
they both are attached now. Both are attached now. Just think it like okay, ball is running with some velocity. Okay, not running. Sorry, ball is moving with some velocity. Okay, and you are running after the ball. You are running after the ball. Okay, you are running with 20 meter per second, and ball is moving with 10 meter per second. Okay, and now you got at some point you got the ball. Okay, you got the ball, and for some distance you again started means continue traveling with some velocity like say 15 meter per second. Okay, will the ball having a different velocity even if it is in your hand?
No, ma'am. Otherwise, your hand will get like disconnected.
I think ball will having some different velocity. Shazan, do you think?
Yes, ma'am.
Ball
Ma'am, wait, ma'am, due to air resistance and all, no, means ma'am, if the ball is kicked with the same speed, then ma'am, the ball will be.
you are having ball in your hand, right?
Mhm.
Can it travel with some velocity other than your velocity? No, no. It means that ball is having the same velocity as that you are having.
Yes, ma'am.
So if we are going to add the mass, add your mass as 40 kg and add its mass as 1 kg. Suppose it's 1 kg, it's corporate ball. Okay, it's 1 kg. Means 40 kg and 1 kg are having velocity. Then we can say this as 41 kg. We can say this now. Now
Yes, ma'am.
your mass has become 40 kg. Your weight has become your mass has become 40 kg, right? 41 because you have taken ball of 1 kg in your hand and you are traveling with 15 meter per second. So we can say that 41 kg is traveling with velocity 15 meter per second. Can we say this? Yes or no? Obviously, yes, no? Again, no.
Yes, ma'am.
Then
Yes,
why
ma'am.
understanding? Here we can write it like m1 plus m2 into v. Okay, the common velocity. Okay, fine. Now what we have to do here, we have to just put the values of m1, u1, m2, u2, and also in here in the RHS m1 and m2. Okay, fine. So putting the values, we'll get the value 60 into u1 3 plus m2 means 140 into u2 is 1.5. Okay, m1 plus m2 means 60 plus 140. How much it will be? I think it will be 200. Will it be yes or no? It will be 200, right? We are getting out of time here. Okay, only this question we'll discuss. So it has taken time. So 15 into 14. 15 into 14. How much it will be? 210. Why? Because this zero has can shifted this point to one right hand side. Okay, so we can cancel this point along with zero. Okay, equal to 200 V. So 180 means it will be 390. I guess 390 is equal to 200 V. So V will be equal to 390 upon 200. So 39 upon 200, about 1.95 time, because this is very close to 40. We can, if we are taking this as 40 by 20, so it will be 2, but it's less than 40, means 1 less than 40, so it will be about 1.95 kind of, or we can also divide this by 2, 39 by 2, so it will be 1 and 1.95. So 1 0 is there in the denominator, so point will go to the left hand side, so we'll get 1.95 meter per second. This we'll get it as our answer. Have you got it, everyone?
Yes, ma'am.
Yes, ma'am.
Shazan, you still are having problem?
Yes, ma'am. I said I got it.
You said you got it. Okay, that's fine. That's perfectly fine. Okay, so you will do these questions in the assignment work. Okay, fine. This 2.1 V3 will be your assignment tomorrow, and also there is one more assignment, I guess 3.2 something. Okay, that also ma'am will assign you to this question you will do, and whichever question you will be having problem, just mark it, and you can also send it to me, and also we'll discuss in the class. Okay, fine. So bye for today.
Bye, ma'am. Thank you, ma'am.
Bye, ma'am. Thank you, ma'am.
Bye bye.